Secure coding practices are essential in the development of software and applications. Secure coding practices are defined as the best practices, guidelines, and methods that developers follow when writing code to ensure that the software is secure and resistant to cyber attacks. Secure coding practices play a crucial role in the development of software that is safe, reliable, and protected from vulnerabilities and exploits. In this section, we will discuss some of the secure coding practices that developers should follow. Input validation is one of the essential secure coding practices that developers should follow. Input validation involves validating user input to ensure that it conforms to the expected format, type, and length. Input validation helps prevent various types of attacks, such as SQL injection, cross-site scripting, and buffer overflow attacks. Input validation is particularly crucial for web applications, where user input is often received via web forms or URL. Parameterized queries are another critical secure coding practice that developers should follow, particularly when working with databases. Parameterized queries involve the use of placeholders in SQL statements, which are later replaced with user input. Parameterized queries help prevent SQL injection attacks by ensuring that user input is properly sanitized and validated before being executed in the SQL statement. Error handling is another essential secure coding practice that developers should follow. Error handling involves detecting and handling errors that occur during the execution of the software. Proper error handling helps prevent crashes, data loss, and security vulnerabilities. Error messages should not disclose sensitive information or provide attackers with information about the software's structure and logic. Authentication and authorization are two critical secure coding practices that are essential in the development of secure software. Authentication involves verifying the identity of users, while authorization involves determining the privileges and permissions of authenticated users. Developers should follow best practices for implementing authentication and authorization, such as password hashing, multi-factor authentication, and role-based access control. Session management is another essential secure coding practice that developers should follow, particularly for web applications. Session management involves managing user sessions, including session creation, maintenance, and destruction. Developers should follow best practices for implementing session management, such as session timeout, secure session cookies, and session regeneration. Data encryption is another essential secure coding practice that developers should follow. Data encryption involves converting sensitive data into an unreadable format using encryption algorithms. Developers should follow best practices for implementing data encryption, such as using strong encryption algorithms, protecting encryption keys, and properly managing key storage. Secure coding standards are another essential secure coding practice that developers should follow. Secure coding standards are a set of rules and guidelines that developers follow when writing code to ensure that the code is secure and resistant to attacks. Secure coding standards cover a range of topics, including input validation, error handling, authentication, and data encryption. Developers should follow industry-standard secure coding standards, such as OWASP Top 10 and CERT Secure Coding Standards. Web application security is essential in protecting web applications from cyber attacks. Web applications are particularly vulnerable to attacks due to their architecture, which involves client-server communication and the use of various protocols and technologies. In this section, we will discuss some of the key areas of web application security. Injection attacks are one of the most common types of web application attacks. Injection attacks involve injecting malicious code into a web application to exploit vulnerabilities and gain unauthorized access to data or systems. Injection attacks include SQL injection, cross-site scripting, and command injection. Developers should follow secure coding practices, such as input validation and parameterized queries, to prevent injection attacks. Cross-site scripting, XSS, is a type of injection attack that involves injecting malicious scripts into a web application to steal sensitive data or hijack user sessions. XSS attacks occur when an attacker injects malicious code into a web application by exploiting vulnerabilities in user input validation or other areas of the application. Developers should follow secure coding practices, such as input validation, output encoding, and using secure communication protocols to prevent XSS attacks. Cross-site request forgery, CSRF, is a type of attack that involves tricking users into executing unintended actions on a web application by exploiting vulnerabilities in session management. CSRF attacks occur when an attacker sends a forged HTTP request from a user's browser using the user's active session to execute an action on the web application. Developers should follow secure coding practices, such as using anti-CSRF tokens and implementing secure session management to prevent CSRF attacks. Broken authentication and session management are vulnerabilities that allow attackers to compromise user accounts and gain unauthorized access to sensitive data or systems. Broken authentication and session management vulnerabilities occur when developers fail to implement secure authentication and session management practices, such as using strong passwords, implementing multi-factor authentication, and properly managing session cookies. Developers should follow secure coding practices, such as implementing password policies and secure session management, to prevent broken authentication and session management vulnerabilities. Security misconfiguration is a vulnerability that occurs when developers fail to properly configure web application components, such as servers, databases, and firewalls. Security misconfigurations can lead to the exposure of sensitive data, unauthorized access to systems, and denial of service (DoS) attacks. Developers should follow secure coding practices, such as configuring servers and applications with secure defaults and properly managing access control to prevent security misconfigurations. Insecure cryptographic storage is a vulnerability that occurs when developers fail to properly encrypt and store sensitive data, such as passwords and credit card information. Insecure cryptographic storage can lead to the exposure of sensitive data and compromise user accounts. Developers should follow secure coding practices, such as using strong encryption algorithms and properly managing encryption keys to prevent insecure cryptographic storage vulnerabilities. Insufficient logging and monitoring are vulnerabilities that occur when developers fail to implement proper logging and monitoring mechanisms to detect and respond to security incidents. Insufficient logging and monitoring can lead to delays in identifying and mitigating security incidents, which can result in significant damage to the web application and its users. Developers should follow secure coding practices, such as implementing logging and monitoring mechanisms and regularly reviewing logs to prevent insufficient logging and monitoring vulnerabilities. In conclusion, secure coding practices and web application security are critical in protecting software and applications from cyber attacks. Developers should follow best practices and guidelines when writing code and designing web applications to ensure that they are secure and resistant to vulnerabilities and exploits. Secure coding practices, such as input validation, parameterized queries, and secure session management, help prevent common types of attacks, such as injection attacks, XSS attacks, and CSRF attacks. Web application security, including identifying and mitigating vulnerabilities, using secure communication protocols, and implementing logging and monitoring mechanisms, helps protect web applications from cyber threats. By following secure coding practices and implementing web application security measures, developers can ensure that their software and applications are safe, reliable, and protected from cyber threats. Mobile applications are a crucial aspect of modern life, with billions of people around the world relying on them for communication, entertainment, and business purposes. With the increasing use of mobile devices, it is essential to ensure that mobile applications are secure and protected from cyber threats. Mobile application security involves protecting mobile applications from vulnerabilities, exploits, and attacks that can compromise user data, breach privacy, and damage the reputation of the mobile application and its developers. In this article, we will discuss the key aspects of mobile application security and the measures that developers can take to ensure that their mobile applications are secure. Mobile application security threats. Mobile applications are vulnerable to a range of security threats, including malware. Malware is a type of software that is designed to damage, disrupt, or gain unauthorized access to a computer system or network. Malware can infect mobile applications through malicious code embedded in the application, or through phishing attacks that trick users into downloading and installing malicious applications. Malware can compromise user data, hijack user sessions, and cause other forms of damage to the mobile application and the user's device. Data leakage. Data leakage is a security threat that occurs when sensitive data, such as user credentials, personal information, or financial data, is accessed or disclosed by unauthorized parties. Data leakage can occur through vulnerabilities in the mobile application or through social engineering attacks that trick users into disclosing their sensitive information. Man-in-the-middle, MID-M, attacks. MID-M attacks occur when an attacker intercepts communications between the mobile application and the server, allowing them to eavesdrop on sensitive data, modify data, or inject malicious code into the application. MID-M attacks can compromise the security of the mobile application and the user's data, leading to serious consequences such as financial loss or identity theft. Unauthorized access. Unauthorized access is a security threat that occurs when an attacker gains unauthorized access to the mobile application or its server, allowing them to steal sensitive data, hijack user sessions, or cause other forms of damage. Unauthorized access can occur through vulnerabilities in the mobile application or through social engineering attacks that trick users into disclosing their credentials. Mobile application security best practices. To ensure the security of mobile applications, developers should follow best practices and guidelines when designing, developing, and deploying mobile applications. The following are some best practices that developers can follow to ensure mobile application security. Secure coding practices. Developers should follow secure coding practices when developing mobile applications. Secure coding practices involve using secure coding techniques and technologies such as input validation, output encoding, and encryption to prevent vulnerabilities such as injection attacks and data leakage. Developers should also use secure communication protocols such as HTTPS to protect data in transit and ensure that user data is not intercepted or modified by attackers. Authentication and authorization. Developers should implement strong authentication and authorization mechanisms to ensure that only authorized users can access the mobile application and its data. Strong authentication mechanisms, such as multi-factor authentication and biometric authentication, can prevent unauthorized access to the mobile application. Authorization mechanisms, such as role-based access control, can ensure that users only have access to the data and functionality that they are authorized to use. Secure data storage. Developers should use secure data storage mechanisms, such as encryption and hashing, to protect sensitive data stored on the mobile device or server. Secure data storage mechanisms can prevent unauthorized access to sensitive data in the event of a security breach or theft of the mobile device. Regular updates and patches. Developers should release regular updates and patches to the mobile application to address vulnerabilities and fix security issues. Regular updates and patches can prevent attackers from exploiting known vulnerabilities and ensure that the mobile application is secure and up-to-date. User education. Developers should educate users about the importance of mobile application security and provide guidance on how to use the mobile application securely. User education can include tips on setting strong passwords, avoiding public Wi-Fi networks, and being cautious when downloading and installing mobile applications from third-party app stores. Third-party libraries and API. Developers should be cautious when using third-party libraries and API in their mobile applications. Third-party libraries and API can introduce security vulnerabilities if they are not properly vetted and tested. Developers should ensure that third-party libraries and API are secure and up-to-date before integrating them into the mobile application. Penetration testing. Developers should conduct penetration testing on the mobile application to identify vulnerabilities and weaknesses in the application's security. Penetration testing can help developers identify and address security issues before the mobile application is released to the public. Conclusion: mobile application security is a critical aspect of mobile application development. Developers should follow best practices and guidelines to ensure that their mobile applications are secure and protected from cyber threats. Secure coding practices, authentication and authorization, secure data storage, regular updates and patches, user education, third-party libraries and API, and penetration testing are all essential aspects of mobile application security that developers should consider when designing, developing, and deploying mobile applications. By following these best practices, developers can ensure that their mobile applications are secure and provide users with a safe and secure mobile experience.